Alright, today we are learning how to multiply and divide rational expressions. And in order to multiply rational expressions, we first actually factor. So that's what we were doing on Monday. So let's multiplying rational expressions, step 1. Is that you always factor everything first. So if you had a hard time with today's quiz and you had a hard time with our activity on Monday, you're going to have to keep working at it because it's going to cause you to not be able to do the assignments in the rest of this chapter if you don't know how to factor. So keep working at it, keep asking for help as needed. Step 2, we are going to reduce or simplify common terms. Or not terms, but factors. Reduce, simplify, common factors. Okay, and again, remember from 5.1, you can't cancel terms that are adding and subtracting unless they're identical to, like something in the numerator is identical to something in the denominator. Okay? You can't just cancel out individual pieces of terms of a polynomial expression. Okay? Then the third step is to multiply the numerators together, whatever's left, and multiply whatever's left in the denominators together. Multiply numerators. And then multiply the denominators. And hopefully you're done because you simplified it before you started multiplying it. Okay? So let's start with an example that has no variables in it. That's always nice to have something with no variables in it. I'm going to move this up. How far can I move it so that you can still see it? Do you want me to leave the steps for now? Okay, example number 1. Okay, so we're going to take 35 over 50, and we're going to multiply that by 30 over 14. Okay, what did I say we need to do first? Factor everything first. Okay, so when we factor a problem that doesn't have exponents and variables in it, we're just factoring the individual numbers, okay? So tell me factors of 35. Numbers that multiply together to get 35. 5 and 7, good. All possible factors of 50, like all of the individual prime factors, what would they be? Well, 5 and 10, but can we break down 10 smaller? So like 5 times 5 times 2, right? Is that as small as it goes? Okay. Then let's factor the 30. What does 30 factor into? 3. So 5 and 6, so 5. But then 3 goes into 6 how many times? 2 times. So is 3 times 5 times 2, is that 30? Do you see how I've broken it down into the smallest possible pieces, right? Okay, how about 14? 7 and 2. Okay, now we're going to reduce stuff, but here's the cool thing with reducing. We don't just have to reduce these 5s and these 2s, but we can actually reduce stuff across from one numerator to the other denominator. So those go away because that becomes 1, and that goes away because that's equal to 1. But then we can get rid of that 7 with that 7, and we can get rid of this 5 with this 5. So now we multiply whatever is left in the numerator together. We really just have 1 times 1 times 3 times 1 times 1, because all of the green stuff turned into 1s, right? So 3 on the top, and then we multiply everything that's in the denominator, so 1 times 1 times 2 times 1 times 1. So 2 in the denominator, so the answer is 3 over 2. If you really want to change it to 1.5 or 1.5, that's fine, but I usually just leave them improper like this. Okay? Now let's try one that has x's in it, or variables in it. Same process though. It gets harder when we throw stuff in that gets in our way. So 3x squared over x plus 2 times x squared plus 3x plus 2 over x. What's our first step? Very first we factor. So what factors? Do I need to do anything with my 3x squared? Not really. If you really, really want to, you can break 3x squared into 3 times x times x. You don't have to, but you can. Okay? Then, can I factor x plus 2? No. Remember on our worksheet on Monday, we had some that were not possible because they didn't factor at all. So we're not going to factor that. The only thing I'm going to do is put parentheses around it so I remember that that's a group. That's a factor together. Okay? Alright, now we have a little bit of tricky factoring here. How can we factor the top of this one? Yeah, Megan? We're not quite there yet. That's where we're getting. Okay, you could write them like this if you wanted to. Because there's no plus or minuses in it, it's all multiplying, it's all individual factors. Factors multiply. When you have the adding and subtracting, you're turning it into a polynomial group. Okay. Alright, now let's factor this numerator. Who can help me? That's a good question. I'm sure other people were wondering. Go ahead, Brian. Okay, so first we break it into 2 sets of parentheses, yeah? So we need to start with an x times an x that will multiply to get x squared. But now we need 2 factors of 2 that add up to 3. So 2 numbers that multiply to get 2 and add up to 3. Okay, so positive or negative? Positive. Both of them positive, plus 2 and plus 1. And then, can I factor the x at all anyway? No, that x is just its own separate little factor on the bottom. Okay? So that might be helpful if all individual factors, you just put them in the little parentheses so that you know what's factors and what's not. Okay? Now we can start reducing common factors. What can we get rid of? Yep, those entire factors can go. And this x can't cancel with that x because this is a group. But this x can cancel with one of those because they're multiplying. So that can go with that. Okay, now everything that's left we multiply together. So in the numerator, what's left? 3 times x. And then can we distribute that through this? So we can actually distribute through and multiply it together, right? So 3x times x is 3x squared, and 3x times 1 is 3x. And then what do we have left to multiply in the denominator? Just a 1 and a 1, and 1 times 1 is 1, and if there's a 1 on the bottom of a fraction, we don't usually even write it. So there's our answer. Let's do a little bit harder one. Then we'll try a problem from your assignment, and then we'll take a little break, and then we'll learn how to divide. That's our plan. Okay, number 3, example number 3. So we're going to start with 2x minus 14 over 4x minus 6 times 6x squared minus 13x plus 6 over 1. And actually, I'm not even going to start by putting that over 1. I'm just going to say a fraction times a polynomial that's not in a fraction. So what do you have to do when you're trying to multiply a number times a fraction times a number that's not a fraction? What do you have to do first? Turn it into a fraction. So how do we turn them into fractions? Put it over 1. Good. Okay. What I've done in my other classes on this stuff is I've actually keeping a list of the people that helped me and give extra credit on the quiz you took today. So I can't remember who's been helping me so far, but this time if you'll specifically raise your hands and I'll call on you to help me, and then I'll make a list of people that have helped me. Okay? Alright, so let's start. I need a volunteer to factor 2x minus 14 for me. Okay, Megan? So take out the 2, so 2x divided by 2 leaves us with x, and negative 14 divided by 2 is negative 7. Perfect, good job. Who can factor the 4x minus 6 for me? Brian? 2 is the greatest common factor, good. What's left inside? 2x minus 3, good, okay. Ooh, now we have a hard one to factor. Who can help us? So we start by drawing what? Parentheses? Yeah? Okay, who's telling me to draw x's on there? Raise your hand so I can tell who's helping me. Is it Eric helping me? Okay. Oh, no, we don't want to do x's on this one. Why not? There's a 6 in front of it. That's going to mess it up. So ignore this for a minute. We need to go through a whole process factoring this first. So that goes away. Okay, so let's factor 6x squared minus 13x plus 6. So we need to start by multiplying the 6 and the 6 together. What's 6 times 6? 36. So we have 6 times 6 is 36. And now I need factors of 36 that add up to a negative 13. Factors of 36 that add up to a negative 13. Yep, but 9 and 4 would add up to a positive 13. So Jacob, negative 9 and negative 4. Thank you. Okay, so we're going to rewrite this whole problem as 6x squared minus 9x minus 4x plus 6. Then we factor by grouping. We factor these two terms. Is there a greatest common factor that goes into 6x squared and 9x? Who knows the greatest common factor for those? Make sure you raise your hands or I'm not giving you credit for helping me. So Eric, 3 goes into both of them, right? So 3 and we're left with what? Oh, there's more than just 3. Yeah, 3x. Okay, good. What's left? 2x minus 3 is correct. Good. Okay, now let's factor something out of negative 4x plus 6, and our goal is to turn this part into 2x minus 3 so it matches. Just a positive 2? Negative 2. So then negative 2 out of negative 4 is positive 2, and negative 2 out of positive 6 is negative 3. Do those match now? So now these two become a group, and these two become one group in our factoring. So earlier when we drew this, we're going to have to modify this. So we have 3x minus 2. So 3x minus 2 is one of our two groups. And then this one, 2x minus 3 is the other group. Okay, can I do anything with the 1? No, it just sits there. Okay, everything is entirely factored. So, what can we get rid of? Stone. On the top and the bottom. Perfect. What else? Raise your hand so I know who's helping. Chase? Yeah, we can get rid of those 2's, right? Okay. Alright. What's going to be all left over? What's our final answer going to be? So x minus 7 times 3x minus 2 over 1. So we don't even need to write the bottom part of it. If you want to leave the answer like that, that's fine. But it would, if you want the answer to match the answer key, then go ahead and multiply it out, like FOIL it. Okay, so that would be 3x squared, and there's a negative 21 and a negative 2, so negative 23x, and then negative 7 and negative 2 is 14. Do I care which way you leave your answer, whether it's like this or this? I don't care, because I want you to make sure you're understanding what we're doing in this section, and I don't want you to get stuck just because you have to multiply it in the last step, okay? So either one of these answers is perfectly fine.
Where'd you get the 23 from?
Okay, so when you multiply these together, you go x times 3x is 3x squared, and x times negative 2 is negative 2x, and then negative 7 times 3 is negative 21x, and then negative 7 times negative 2 is positive 14. And we can add the negative 21 and the negative 2 together, which gives us negative 23x in the middle. Alright, I'm going to hand out your assignment, and when you get it, I want you to do problem 1. That doesn't mean we're done with notes. That just means that we're going to start practicing by doing some problems on the assignment before we learn division. Okay?